Chapter 3, Parallel and Perpendicular Lines, Section 1, Lines and Angles. So a lot of this is review, which is good. You're going to be seeing it throughout the year, so it'll get easier as we go over it more and more. We already know that parallel lines are two lines that are coplanar and they never intersect. So looking at the diagram, we can see a variety of parallel lines shown in this cube or rectangular prism if we don't know that all line segments are congruent, all edges are congruent. So let's name a few parallel lines. So draw the diagram, sketch the diagram as it's shown in the picture. Using different colors would be helpful. And we know already from the picture that we would use these arrows to show that BC and AD are parallel and that AE and BF are parallel. But let's name a few more. So we have that line DH is parallel to what line? Well, on the same plane, so DH is on this back plane. On the same plane parallel to DH would be line CG. Now, looking at line EF, what would be parallel to line EF? Well, again, line EF is on this bottom plane, or we could think of it as on this front plane. Either way, parallel to line EF could be line AB. You could also say that parallel to line EF would be line HG. This back line is parallel to this front line and they lie on the same plane. Now, skew lines never intersect and they're on different planes. An example of skew lines would be lines AB and CG. Now, by definition, skew lines are non-coplanar and they never intersect, and they're also not parallel. So, by that definition, you can't say that AB and HG are skew. First of all, there's a plane that connects AB and HG, so they would be parallel because they're coplanar. You have to say two lines that are not intersecting, they're not coplanar, and they're not parallel. So their slopes aren't parallel and they lie on different planes. Now, parallel planes would be the entire plane. So we're not just talking lines anymore. We're talking actual sides of this rectangular prism, which is representing planes going on all different directions. Well, we could say that plane ABCD, which is this top plane, is parallel to the shaded plane on the bottom, plane EFGH. So the actual planes will never intersect, which we talked about in Chapter 1. Now remember, parallel lines are coplanar. This question is asking which planes contain line AB. Well, line AB is in the top plane, it's in this side plane, but it's also in any plane that can be drawn through this line. So planes ABCD, which would be this top plane because this is point C, this is point D. Plane ABFE because this is FE and this is F. And plane ABGH also contains line AB. You need to be able to visualize the planes that can be drawn. So in this rectangular prism, there's not infinite amounts of planes because we're just working with these 8 points, but there is a plane that can be drawn. Now on this plane ABGH, we can say that line AB is parallel to line GH, AH is parallel to BG, and we can work with lines in the plane as well. So looking at this diagram, let's just name a few things. So this is a rectangular prism. So we're assuming a few things here. We're assuming that opposite sides are parallel. So this goes for all opposite sides, no matter what planes you're talking about. We're going to use 3 arrows to differentiate them from the top ones. But it works no matter what plane we're talking about. And we're going to talk about parallel lines, perpendicular lines, skew lines, parallel planes, and perpendicular planes. So sketch this figure and label those topics, and we'll list a few examples underneath each one. So starting with parallel lines. An example of parallel lines, and remember when you're doing lines, you actually do the line over the segment, would be lines AB and CD are parallel, so you would write it as this. What other lines are parallel? Line AB and line EF. Line CD and line GH. Line AD and line EH. Line BC and line FG. And fairly importantly, we need to consider the plane that cuts through in this direction. So line AB and line GH are parallel. And the plane that cuts through in this direction. So line CD and line FE are parallel as well. Now talking about perpendicular lines, we could say that line AB is perpendicular, we use this symbol, to line BF, because we're talking that this is a rectangular prism that represents planes. So these are all right angles. All of these are right angles, is what we're assuming. This information would be given to you on a test, though. So line AB is perpendicular to line BF. Line AB is also perpendicular to line AE. And talking about that blue plane which we just drew through the center, line AB is also perpendicular to line AH, and it's also perpendicular to line BG. We can do the same thing for line CD. It's perpendicular to CG, to DH, to AD, to BC, to DE, and to CF. Those are just a few examples of perpendicular lines. Now moving on to perpendicular planes. Well, we can say that plane CDGH is perpendicular to plane ABCD. You would just write it as plane ABCD is perpendicular to, you can use the symbol, plane CDGH. Plane ADEH is perpendicular to ABCD. It's also perpendicular to EFGH, or CDGH, or ABFE. So the planes are perpendicular. The parallel planes, again, you would write it as plane ABCD, and you could use the symbol. It's parallel to plane EFGH. Plane CDGH is parallel to plane ABEF. Now before we move on to different types of angles, which again we've already talked about, but just to reiterate, you label your lines usually with a script lowercase letter. You can also label it by 2 points, but in this case they chose letters. We're labeling our angles with numbers rather than 3 points. If there's a number in the interior of the angle, you can refer to it as angle 2. Otherwise, it must be referred to as angle ABC, or whatever the points are. Now, it's important to note that when you have 2 lines cut by a transversal, so T is normally the transversal, a transversal is a line that intersects 2 or more coplanar lines at distinct points. Now, when the transversal intersects two or more coplanar lines at distinct points, it forms an interior and an exterior. So angles 3, 4, 5, and 6 are interior angles, and angles 1, 2, 7, and 8 are exterior angles. Now, we've already talked about the different types of angles. Now, we can only say that alternate interior, corresponding, and alternate exterior are congruent to each other when the lines given are parallel. So here we're just naming the different types of angles. So copy down the charts and the corresponding pictures and examples for both definition example and the picture for all four of these. Alternate interior angles are non-adjacent interior. Non-adjacent meaning they're not next to each other. And they're on opposite sides of the transversal. So if this is the transversal, one is on the left and one is on the right. Now keep in mind these pictures can be turned. So it's not always going to be left and right. But if this is the transversal, if this is the line intersecting two other lines, 4 and 6 are alternate interior and 3 and 5 are alternate interior. The only time we know that they're congruent to each other is when the lines that are given are parallel. So if I gave you line L is parallel to line M, and it's intersected by transversal T, then you could say that angle 4 is congruent to angle 6, or that angle 3 is congruent to angle 5. But here we're just talking about the different types of angles, not their measures yet. Now, same-side interior angles are interior angles that lie on the same side of the transversal. So 3 and 6 and 4 and 5. Fairly simple. But again, when we're talking about parallel lines, if I give you that L is parallel to M, and it's intersected by transversal T, angle 3 and angle 6 are supplementary when the lines are parallel, and angle 4 and angle 5 are supplementary. Corresponding angles lie on the same side of the transversal T and are in corresponding positions. So if you think of it as the top 4 and the bottom 4, when you look at the top right and the top right, those two are corresponding. Bottom right, 3 and 7 are corresponding. Top left, 1 and 5 are corresponding. Bottom left, 4 and 8 are corresponding. It's easier when we color code these, so if you have different colors, I'd use them here. Again, if it were given that L and M were parallel, you could say that all of these pairs are congruent to each other. So 1 is congruent to 5, 4 is congruent to 8. Here we're just talking about the types of angles, not the measures yet. Finally, alternate exterior angles are non-adjacent exterior angles that lie on opposite sides of the transversal. So this is interior, this is exterior. Alternate means opposite sides, so 1 and 7 and 2 and 8. Again, if the lines were parallel, they would be congruent, and 2 and 8 would be congruent. But we cannot assume anything about the measures here unless the lines are parallel. The only time you can assume anything about the measures is if you're given that two things are lines. So let's say you're given line L and line M. You can use vertical angles. So you would be able to say 1 is congruent to 3 and 2 is congruent to 4. Since we also know that this is line L, you can also say that 1 is supplementary to 2. 2 is supplementary to 3 because we know that T is a line. So you can use vertical and you can use supplementary when the lines aren't parallel. Otherwise, you can only find the measures of these if there's missing measures. You can't say that alternate exterior angles are congruent unless the lines given are parallel and cut by a transversal.